For this video, we're going to look at how to create two different types of numbered lists, a collated list and an uncollated list. If you're not familiar with these terms, let me explain it in a program that you've probably had some experience with. In Microsoft Word, when you have a multi-page document and you print it, it prints from the first page to the last page. But let's say you want to print 5 copies of this document. You'll print pages 1 through 5, then 1 through 5 again, then 1 through 5 again, etc. This is what's known as collated printing. And you can see this feature right here, collated. Print pages 1, 2, 3, then print 1, 2, 3 again, then print 1, 2, 3 again. But there's another option here called uncollated. And this is where if you had a 5-page document, you'd print all copies of page 1, then all copies of page 2, then all copies of page 3, etc. So this is the difference between a collated list of numbers and an uncollated list of numbers. Back in Excel, let's see how to create a collated and an uncollated list of numbers. Then I'll show you where they have practical application. Then at the very end, I'm going to show you how to create collated and uncollated lists when the data source is an expanding data source. To begin with, let's look at how to create a collated list of numbers. I'd like to create a list of numbers that goes 1 to 5 times. So that's a total of 25 numbers. We'll click under the word collated, and the first thing I need to do is generate a list of 25 numbers. And to do that, I'm going to use the sequence function. And I'd like a list of numbers from 1 to 25. So I just tell it how many rows I want, hit enter, and I get my list of numbers from 1 to 25. But I need that list to go from 1 to 5, 1 to 5, 1 to 5. In order to do this, eventually we'll need to do a little bit of modular division. And for that modular division to work, my sequence numbers need to begin at 0. When you just use the default, this is how many numbers I want argument, 25, sequence always starts at 1. So what we'll need to do is go back into the function. After the 25, for the rows, we'll tell it how many columns we want. The default is 1, and I could skip this and just put another comma, but it might make it a little confusing for some people, so I'll go ahead and just say 1 column. Comma, and I wish to start with 0 instead of 1. The default step value is 1, that's what I want. I don't need to declare that. I'll hit enter, and now my list of numbers is 0 to 24. Now in order to get this list to loop 1 to 5, 1 to 5, 1 to 5, or in this case 0 to 4, 0 to 4, 0 to 4, I need to perform modulo division on these values. So going back into the formula, I'm going to wrap this sequence function inside of a mod function for modulo division. The number I'm going to be dividing are all of the sequence numbers from 0 to 24, and I wish to divide each of those values by 5. Close parentheses, enter, and now I have the looping list of 0 to 4, 0 to 4, 0 to 4. Now what I really wanted was 1 to 5, 1 to 5, 1 to 5, so this is just a simple matter of going back into the function and adding 1 to each of the results. And now I've got my looping list of 1 to 5, 1 to 5, 1 to 5. So if you wish to create this type of looping list, here's your formula. But what about an uncollated list of numbers from 1 to 5? This would be where it shows the number 1 5 times, then the number 2 5 times, then the number 3 5 times, etc., etc. We want a list of 25 values, so we'll start with the sequence function and ask for 25 values. So now we have 1 to 25. I'm going to divide each of those values by 5. Now this generates a series of fractions and whole numbers. But notice the sets. The first 5 are between 0 and 1. The next 5 are between 1 and 2. The next 5 are between 2 and 3. So what if we were to round each of these values up to their nearest whole number, their nearest integer? Well, we can do that by going back into the function and wrapping this sequence function inside of a ROUNDUP function. ROUNDUP rounds the fraction to a specific number of digits. In our case, we want to round up to a whole number, so we don't want any fraction at all. So we're going to put a 0 in here. Close parentheses, enter, and now we have our list of uncollated numbers, starting with 1, 2, 3, 4, 5. But what practical value would we have in creating such lists? Well, let me show you a perfect example where using these two formulas will help you build a table. Here I have a cross-tabular structure. I have a table of columns that represents months, and I have a table of rows that represent products. And at the intersection of those two tables is some type of calculation, like the total sales of that product in that month. I need to turn this into a regular table. Now I know I could pull this into Power Query and perform an unpivot operation and turn this into a proper tabular structure. But let's say you don't know Power Query, or you just don't want to use Power Query to solve this problem. So we're going to build this table right here. So we're going to start with a series of headings. Our first column is going to be month. Our second column will be product. and our third column will be sales. The first step in creating this table is to take all of these sales and turn them into a single column of values. Let me go ahead and put a line under my heading, and I'll make my heading bold. So under the word sales, to take an array of values and turn them into a single column, we're going to use the toColumn function. The array we wish to turn into a single column is going to be the array of these values. Close parentheses, enter, and there's our list of values. So we have 60 values in this column, and if I highlight them, you can see down at the bottom, there's a numerical count of 60. Now that we've converted that array of values into a single column, we can now create the repeating list of months, January through December, to match up with each of those values. So we'll go into the word month, and we're going to start off with a sequence function. Now I know I want 60 values, and I could just type in a 60, close parentheses, and hit enter, and get that list. But if this list is going to grow, because maybe we'll only start with January and then over time get to December, I want this to be a dynamic counting of sales values turned into this column. So instead of hard coding the 60, I'm going to count the number of rows that are occupied by those sales. And I can do that very easily with the rows function. I'll select the cell that holds the output of that toColumn function and then add a pound sign to that, because that will tell it to scan the entire spilled array. Close parentheses, hit enter, and I have my list of values from 1 to 60. Now you could have also done this with something like a count function, but I wanted to use the rows function in case you weren't aware of it. Now as before, we're going to eventually perform some modulo division on these values, and I need the values to start with 0 and not 1. So going back up into our sequence function, the number of rows created is a byproduct of the rows function. I'd like a single column of values, which is what I have right now, but I want those values to start with 0. I'll enter, and now I have a list of 0 to 59. In our previous example, we wanted a looping list of 1 to 5, 1 to 5, so we perform modulo division using 5. In this case, we'd like a looping list of 1 to 12, 1 to 12. So back in the function, we'll wrap this sequence inside of a mod function, comma, and the divisor will be 12, close parentheses, and now we have a looping list of 0 to 11, 0 to 11, 0 to 11. Now, I'm not a big fan of hard coding that 12, because again, if this table grows over time and we might only start with 3 months, I need it to be 3, but if it's 6 months, I need to be 6. So we need that 12 to be dynamic. So we'll go back into the formula, and just like before where we use the rows function to count the number of rows output by that spilled function, I'll use the columns function to just count the number of columns between C2 and N2. Close parentheses for the columns function, enter. We're still getting the looping list of 0 to 11, 0 to 11, but at the end of this, we'll see the advantage of being able to count those columns dynamically. So when we don't have a complete year, we're not getting a looping list to 12. It's these numbers 0 to 11 that are going to allow me to return the appropriate month name. So if I'm sitting in this cell 194.40, and I can see that down here 194.40, I want to return the word February. So for every number that appears in the list from this position, I want it to say February. It's these numbers that are going to allow me to perform a lookup to say, hey, what position are you in sales value? Let me go get your associated month name. And this is going to be performed by an index function. Now, since the first column of values for January is actually in position 1 according to the index function, this 0 will not work. In fact, all of these numbers are basically off by 1. So we need to make an adjustment for this for the sake of the index function. So we'll go to the end of our formula and add 1. Now we have our looping list of 1 to 12, 1 to 12, 1 to 12. These numbers will serve the index function to return the month names. So back at the beginning of the formula, we'll wrap this inside of an index function. The array that we're scanning is the list of months, comma, and the position that we're going to return from is the value dictated by the mod sequence rows columns function. We'll go to the end of this, close parentheses, hit enter, and now we've returned the heading names for each of the related months. Now on to returning the products. For each set of 12 months, I want to see the same product name. So from January to December, I want to see bread. For the next January through December, I want to see cheese. For the next January through December, I want to see milk, etc., etc. So we don't want to show bread, cheese, milk, flour, sugar in a repeated fashion. We want bread 12 times, cheese 12 times, milk 12 times, etc. So the first thing we need to do is create a list of numbers in the same length as the number of values we have in the sales column. So to do that, we're going to use the sequence function, and we need a list of numbers that matches the number of sales from the two-column function. So to count that up, we'll do what we did before, and we'll use the rows function to point to cell E11 and point to its spilled array. Close parentheses for rows, close parentheses for sequence, hit enter, and now we have a list of 1 to 60, just like before. I need to divide each of these values by 12 because I want 12 ones, 12 twos, 12 threes, etc. So let's take this sequence and divide it by 12. Now we're going to get a lot of fractional values returned. These will eventually be rounded up to give us the numbers 1, 2, 3, 4, etc. But before we do that, as before, I don't like the fact that this 12 is hard-coded. I want this to be calculated dynamically. That way, if I only start with 3 months, I want it to be a 3. At the end of the year, when I have 12 months, I want it to be a 12. So just like before, we'll use the columns function to count the number of columns from C2 to N2. Close parentheses, enter, and I get the same answers I had before, but now it's been dynamically calculated instead of statically declared. I want all of these values to be rounded up to their nearest integer, their nearest whole number, so I'm going to wrap this sequence inside of a roundup function. We want to round it up to 0 decimal places. Close parentheses, enter, and now notice we have our looping list of 1s, 2s, 3s, 4s, and 5s. These will serve as the basis for the index function to return the associated product. So back at the beginning of this formula, we'll wrap this inside of an index function. The array we're scanning is the list of products, comma, and the returning row number is the value determined by the roundup sequence rows columns formula. We'll go to the end, close parentheses for the index, enter, and now we see 12 breads, 12 cheeses, 12 milks, 12 flours, 12 sugars. So there is a practical application for creating collated or uncollated list of numbers in service of an index function to perform lookups. I mentioned several times throughout the building of this table that I wanted things like month names to be dynamically discovered, or product names, because I may add additional products, or if I start with just January, every month when I add a new month, I want that to be discovered. And I have built that in, but there is a bit of a problem. Let's say we remove all of the sales after March. Notice in my table, it does show January through March, but because I'm mimicking the height of the sales table, and the sales table is bringing in everything in the range at which I predict data will eventually exist, I'm getting a bunch of zeros. Likewise, if I were to get rid of some of my products, I still see the breads and the cheeses, but then I end up with a bunch of zeros for products I haven't introduced yet. So we need the scanning of the data ranges to be more dynamic. To do this, we're going to take advantage of a very new feature in Excel called the TRIMRANGE, or the dot operator. Now, if you don't have this, it could be because you're running an older version of Excel and might require an upgrade. But if you're running the newer version of Excel, it could be just you're a little late in the update cycle. So keep your eyes peeled, and it should appear soon. If we go back to the sales formula, where we performed the 2 columns, we hard-coded in this array of C3 through N7 because that's where we eventually knew data would appear. But if we were to remove some of that data, the formula is still examining all of the cells in the range of C3 through N7. But we don't want to see everything all the way through December for the last product. We only want to go as far as months go and as far as products go. So C3, being the upper left corner of this array, is basically anchored. We're always going to have something at least in that one cell. But anything after that is variable. So to indicate that to Excel, we're going to click in the formula directly after the colon and before the reference of what would be considered the bottom right corner of the array and place a period or a dot. This dot operator notation tells Excel that if you go all the way to N7 and there isn't any data there, start backing up until you actually hit some data and let that be the end range. When I hit enter, notice I only get those 10 numbers. Now, the months and the products aren't correct because we still have to modify those formulas, but just the numbers are what we're concerned with right now. And if I were to highlight these numbers and copy them and then paste them, we get more numbers. And if I paste them again, more numbers. I'm going to hit undo a couple times. And so now with my formula being start in C3 and then go all the way down to N7 as my limit, so I won't go past N7, but it also means I won't pull in blank cells up to N7. And if I highlight all these values, you can see down at the bottom I have a numerical count of 60 because there are 60 values in this table. Obviously, this end range of N7 would have to be a cell that you'd pick that would represent the furthest cell in the array, or the absolute limit of the bottom right-hand corner of your array. So with that problem solved, we'll go to the month formula. Now in this, I do wish to scan all of the columns C2 through N2, but the return values are really being dictated by this mod sequence rows columns equation. If I highlight the columns formula, it tells me there are 12 cells that have data in them. If I were to delete some of those months, notice in the data I have zeros where those months used to reside. If I highlight the columns function again, it's still counting 12 because C2 through N2 is a hard-coded range, and it will always count 12. So what if we were to go into this columns function and use that dot operator? We'll start our scan for month names in C2. The furthest point we will scan will be N2, but if something isn't in N2, we'll start backing up until we actually hit data. Now right now, all 12 cells are filled, so we get the January through December. But if I were to highlight half of that year and delete it, notice now we go January through June, January through June, January through June. Highlighting that columns formula, it says there are 6 things that it sees. In fact, if I were to highlight all the months except for January and delete them, we get nothing but Januaries. Because according to this columns function, there's only one thing in that array of headings. So we've made sales more dynamic, we've made months more dynamic. Now it's time for product. This has the same issue. The scanning of those months need to match the number of months we have. And right now, if I highlight this, it says there's 12, and it's always going to be 12 because even though this is dynamic, that 12 is always going to be there. It's essentially like a semi-hard-coded value. Well, let's go after the colon and place that dot operator. We'll hit enter. If I were to delete some of this monthly data, since I only have 3 months, I'll get 3 breads, 3 cheese, 3 milk, 3 flour, 3 sugar. If I did not have that dot operator in place and I deleted those months, it wouldn't understand to go to the next product until it's exhausted all possible 12-month options. So I go back in here, add the dot operator, and now my products are correct. There we have 2 examples of how to create lists of numbers, either collated or uncollated, and then using those lists of numbers to take a cross-tabular table and turn it into a proper table. Let me know your thoughts in the comments. How many of these features do you think you could use? Don't forget to download the sample file from the link in the video description so you can follow along, look at the answers, or just download all of the step-by-step instructions. Thank you for watching, and remember, at BCTI, the learning never stops.